We are recording, I think. Yep, I think so. So to be fair, this one is pretty dense, guys. It's going to have a lot of parts to it. And like I said, you're more than welcome to kind of listen in the background. And obviously, this is for documentation purposes. But to be fair, this one is pretty dense, right? We're going to start off today with topography. Obviously, start off with a nice foundation and continue talking about the project. You'll notice I put the assignment on Miro. So of course, let's take a small gander. But essentially we're of course continuing in Rhino and really going to start talking about the laser cutter model. So we're going to physically make this now, which is a really big step to go from the computer to obviously reality. There's some limitations, in reality, not so much in the digital realm. However, for this next exercise, it is to develop our skills in the digital design and fabrication in the context of architecture and to discover the techniques of utilizing the laser cutter for its speed and accuracy. The model making, our first task will be to select a 48 by 48 foot lot of space anywhere in San Antonio. So of course I'll do that with you guys today. It is recommended that each selection has some sort of slope, right? It should be sort of vertically interesting. Obviously don't pick, the world's flattest spot in San Antonio, otherwise you won't have a lot to work with. Maybe a topography or two. And to be fair, it's 48 by 48 feet, so, there's, it's a good wide range. Not too big though. Actually, the first time I did this, as you can see in the model, we did 1,000 feet by 1,000 feet. And that was an absolute mess. Even though it did make some pretty cool models, it took far too long, and I learned a lot as a professor in the process. However, my example is going to be in San Pedro Park, and we'll do that together today. To be fair, step 1 through 4 is really of the entire process, and it's not going to help a whole lot today. Essentially, what we're going to be looking at today is just step 1. And there might be, of course, a part 2, part 3, and part 4 for each of these steps, just because, we're going to start making the entire model. You'll notice that actually there's a couple of requirements for the model, but again, the only one that applies for today, at least in this recording, is going to be the topography model. So I hope to really hash out a lot of that. But the reason for so many parts is, well, I'm going to show you, we're going to go back to those abstractions. I'm going to show you how to unfold them and laser cut them, right? That way you don't have to sit there and cut every single piece by hand, right? Which is definitely something, if you've taken D1 or D2, you're quite familiar with how long this takes in terms of making stuff. So again, becoming more organized and of course using the technology to make it easier for ourselves, maybe save money, and actually make it even look better, arguably. So of course, craft and accuracy and creative efforts. And to be fair, we'll probably even spend more than 3 weeks on this. Very often, we usually need about 4 or 5 weeks for Revit. So to be fair, we even have 5 weeks on this. You guys have been going so fast on the other assignments. We do have an extra 2 weeks, if you will. To be fair, that's only like 4 class periods, but I think we're going to need it for this one. Of course, I'm going to start bringing in some models to show you what the final product looked like. I totally forgot today, but I'll start bringing those in Thursday and kind of leave them about the studio. But let's get started. Obviously, we need a 48 by 48 lot of space. And at least for today, I like to use my tried and true spot in San Pedro Park. So let's go ahead and go there first. And one of the first sites that I like to bring up, and it's a very easy find. Of course, in any search engine, all you have to do is type in hydrology and contours San Antonio. And boy, do I wish there was a site like this for every city, but that is not the case. Thankfully, Bexar County has really invested in themselves, and they found out all the waterways and topography for the entire county of Bexar, right? And it's a very useful map, and this is exactly what I mean. We just need a 48 by 48 plot anywhere in San Antonio. So, I mean, don't get too distracted, but we do need something visually interesting. So one of the first things that come to mind is, at least for myself, San Pedro Park. Right next to San Antonio College. Hey, we're about right there where this big depression is, right, for the MLC building. A lot of people notice that, of course, our building goes underground. and things like that. It's a very large building, and to be fair, a lot of topography around it. But tried and true, of course, San Antonio, San Pedro Springs Park is one of my favorites, and I'm going to be specifically looking at this corner because it does have a lot of topography that I can look at, and a great example of a hill that we can work with. And to be fair, I've always wanted to put an observation tower at the corner of a park. I mean, why not get at least a little bit invested? So a couple things that we need. We'll need this contour map, and of course I want to show a different way that we can do this process as well. A couple of options here, especially if you're in studio and you're looking out in the middle of nowhere, and maybe there's not a hydrology and contours map for your site that you're working with in studio. So I do want to give a couple of options, such as terrain to STL. And again, that one's a little harder to find. You got to type in terrain to STL in your search engine. Anyway, so let's go ahead and get a Google Earth shot as well of this location, because I will need a measurement. So just in case you've never done this process before, and again, this might be a review. Of course, if you've already taken D3, D2, or D4 even, we do this process quite a bit, where we basically overlay our site image with our contours and hydrology. Where was I last time? Oh man, I was in Venice. Oh yeah, I was explaining Venice. Very often I go on vacation, even in my office, and tour Google Earth all the time. But let's go to San Pedro Springs Park. The one and only. Whee! Love it. And we'll zoom in as much as possible, right, so we can get kind of the clearest shot, and we'll let that load out. And that's looking pretty good. Right now you can start to see that there's a little bit more information. I could start to think about adding that, and as you can see, the current state of this corner is pretty sad. In fact, it goes into a stair, and then literally this is where the sidewalk ends, right? It's just a stair to nowhere, and unfortunately has never really been considered. So I think it's actually a great opportunity, and to be fair, you're welcome to choose the exact same site. Like I said, this isn't for studio, and we're not going to be critiquing its design or its placement or things like that. But some of you guys might need it to feel a little bit more real. So I want to offer this one up as a suggestion. The corner of San Pedro Park needs some help, right? It's got a very sad stair, and by golly, we're making a stair observation tower. So it makes a lot of sense to solve something in this process. In fact, I could even use it in my portfolio as a little side quest, little side project. But we do need a couple things. We'll need a measurement on Google Earth. And to be fair, Google Earth Pro does work a little bit better. However, most of us don't have Google Earth Pro, even though it is free. So I will throw it out there. Definitely worth your time and investment if you're an architect student. Yeah, it is free, and at least the features that we need. Anyway, so let's take a look. We do need a measurement. So right here you have a little questionable, I guess that's a ruler, but it is a ruler, at least a measuring tool. I want to click really anywhere on the map, but maybe not in my topography. Obviously, I'm going to be tracing and using that, so maybe I don't want things to get too much in the way. So I'm going to go ahead and draw a certain distance, and it really doesn't matter what distance as long as I know what it is. So yeah, for instance, 6.23 meters, I have no idea what that is in feet, so of course I need to switch it to meters first, which in my case usually pops up first. And doesn't seem to be the case. Usually, maybe my screen's too small. Do I need to zoom out a little bit? No. Usually this window actually pops up. Usually it's very easy to switch it to feet. Yes, well, we got some instructions. I don't know why I'm stuck in meters. Is anybody else familiar when this is not working? Maybe I have to make the measurement.
About 14 meters.
Let's see. Oh, okay, maybe I can switch it as soon. There we go. So I gotta make the measurement first, apparently. And by golly, I was actually shooting for 30 feet and nailed it. Anyway, happy coincidence maybe. But I'm going to hit done. That way I can basically keep this there. And we just really need it there for reference, right? So that we can understand any sort of measurement. It could be 20 feet, it could be 15, 5, 1. Well, 1 would probably be actually pretty inaccurate. Don't use 1. But yeah, something in the 30-foot range, that's perfect, right? Because we really just need it for reference. Now keep in mind, we also need a completely two-dimensional shot. So that's not going to really work for what we need. In fact, since it's a perspective, it's not very accurate, right? In fact, there is no scale to a perspective. So we do need a top-down shot. So do make sure that you kind of realign your camera, if you will, right? And make sure you get the topmost shot. I usually like to put north towards the top as well. But really from here, we just need a screenshot. So on the Mac, you can use Command, Shift, and the number 4. And it's going to bring up sort of like a snippet, right? If you have Windows, you can print screen button. So of course there's a print screen button on Windows mostly. Or if you don't have a print screen button, you can type in virtual keyboard on Windows and it'll bring up a virtual keyboard, right? And it has a print button on there as well. There's also an app called Snippet. Usually it's even embedded in some Windows computers. But yeah, most of us are pretty familiar with taking a screenshot, so hopefully that's not too big of a problem. Now in my case, I accidentally made the world's smallest screenshot, so I need to hold on the Mac and just make sure that my measurement and my sight is in there somewhere, right? Just because I will be getting more information. So snap it, we got it, it's good to go. The next thing that we need is, of course, actually the contours. So as you can see here, I can only zoom in so far, right? And good thing too, because if I zoom in a little too far, it actually redevelops the topography lines, which is great, especially if I'm using a macro site section and I don't need to see all those lines. Absolutely. And to be fair, this is a really nice GIS map. Again, more reason that I wish it was out in the hill country where I need it the most. Anyway, so that's looking pretty good. And as you can see, it's definitely sloping down. And we can definitely tell that information from just looking at it, right? Yeah, and it's not that bad, but it is a stair to nowhere. And quite a drop. In fact, there's a lot of bedrock right there. I've kind of always wondered why that is, or why we decided to put a road there, and really just the gigantic hill of Olmos Park. But anyway, I'm getting off topic. So we need to get some more information. We need to get a screenshot of this, and we do want to make sure that the area that we gave that measurement is of course in there as well. So I'm going to take another screenshot and ballpark it. Fair enough. Now the next thing we need to do is overlay those two images. In fact, I need to start basically transcribing it for Rhino. So of course, I'm starting off with a new project today just so that I can focus on topography. I'm going to work with my top section, and again, as you guys know, the default is millimeters, so do make sure that you switch to feet. We're already in feet, so we're good. And in my case, I'm going to start with a rectangle, or in my case actually a square, and make sure that it's 48 feet by 48 feet. I just kind of want to see what that looks like for myself. That way I have a better idea of what's going on and everything like that. Next thing I want to do, maybe make that a little bit bigger for myself. We're going to be sticking in the two-dimensional for now. So I want to type in picture. And if you have Rhino 5 or Rhino 6 actually on the computers, I notice frame is also another way to put pictures in. That is obviously changed in Rhino 7 and 8, but just in case somebody's watching a video right now and they're working on Rhino 6, frame is going to work for you, not picture. Anyway, throwing that out there. But let's go ahead and get those screenshots. So I'll go to at least my desktop. Pretty sure I got those screenshots. Maybe my screenshots go somewhere else. To be fair, I don't think I've taken a lot of screenshots on my computer yet. Or on this new computer. Could have swore I got them though. There we go. Not sure where they're located. I guess I could always right click, see where they're at, but at least for today we're going to need both of those. Let's go ahead and open. Oh, I see. Maybe it's just the program wasn't allowed to see them yet. And so I'm just going to arbitrarily put them. They don't need to be just any sort of scale yet. I'm going to go ahead and get the other one. Get that one. And we have both. Right, and the first thing we need to do is, of course, line these up and group them That way, of course we don't lose track, and we make it a little easier to trace, right? So first thing is we can click on the picture itself. We can go over to our properties, and of course use the material bar to also make it transparent, which is extremely helpful, right? So of course I'll take that. Oh, man, I'm telling you, screen recording and Rhino, they just don't like each other. Even on a brand new computer. Go figure. Anyway, it got there, and hopefully there's not a jump in the recording as well. But yeah, now we can obviously see the topography on that map, right? And so I'm just going to arbitrarily at first, at least try to get them lined up. And one of the things I may have not gone over yet is being able to lock things and unlock things. Of course, I can just type in unlock, but I do find that a little bit easier, that some aren't moving around essentially while I'm trying to do things. Right now it looks like my grid snap is on of some kind, or ortho, that's what it is. So if your ortho mode is on, you'll notice you can only move in perfect 90-degree directions. I don't know if anybody's run into that problem, but yeah, sometimes your orthographic button is engaged. So anyway, I'm just gonna ballpark it, right? For the most part, the street's actually pretty close. So I'm just gonna make that a little bit bigger. Again, I'm gonna hold shift so that it stays proportional. Be very careful with that. You guys all learned that the hard way with Illustrator. But yeah, we're gonna get it pretty close. In my case, I still can't see the streets very well. So that's looking pretty good. And I can imagine that the topography probably doesn't go into the road. And to be fair, I would spend a lot more time with this the more that I needed to be accurate. So let's turn off yeah. And as you can see, we're getting pretty close. Obviously, I'm just trying to align it with that edge and of course the park edge. So fair enough, right? And you can definitely see where the topography happens for that image. And fairly close, right? Not too bad. So I'm gonna unlock that so that I can grab both and I can group them, right? Just because I don't want to have to accidentally do that again or accidentally move one. Now we're good. They're locked in together. The only unfortunate thing is if I do want to make changes to one individually, I do have to ungroup them first. So I would make those changes before you group them. However, we can trim them together, which is really nice because I really just want to talk about this section. But my measurement's over here. So I do need to make this image to scale first. I do know that my line is 30 feet and that I can draw a line at 30 feet. So I'm going to do that first. 30 feet, enter. And again, it might be a review for some of us, but absolutely brand new for some. And you guessed it, we're going to line up our image 30 feet to our actual model 30 feet. So of course, first thing I'm going to do is move this piece, and on Google Earth Pro it's represented as a red line, and that is from tip to tip. Now unfortunately on Google Earth it sort of makes it cartoony and I think a little bit more easier to look at and maybe to identify, but we're actually going to use the center of this circle. Don't use this edge and don't use that edge. You'll start to have some inaccuracies. Again, not that it's pertinent for this class, but again in Studio that could be very detrimental. So I'm going to use that as my base point, and I'm going to lock it onto that 30-foot line, and then basically just scale the image to that line. So I'm going to type in scale, enter. It's going to ask me for a base point, which of course we already know. It's going to ask me for the reference point, which in my case is the other center of that circle. Now, as you can see, my measurement's slightly off. So I'm not going to hold shift here because I do want it to get as close as possible to that 30 feet. So I'm going to get the center there. Nailed it. And now in this case, now it's going, okay, now what do you want that line to be? Of course we want that line of the image to be 30 feet. So we'll click on that 30-foot marker, and to be fair, it's a little off. Of course I can make that Google image, I could rotate it a little bit and get it a little bit more accurate. Again, not a huge deal. But now we have an image that is to scale. So this 48 by 48 feet now is what it would look like in real life. And as you can see, yeah, most roads are about 45 feet, at least with double lanes. To be fair, this is a pretty unique situation on San Pedro Avenue. Anyway, not important. So let's get our piece now that we're good. So I'm basically going to line it up, right? And as you can see, I got plenty of topography in there. And I'm having a hard time with, obviously, the transparency there. So you'll see if I zoom in, zoom out a little bit, I can, get the computer to do what it wants. To be fair, I am screen recording, so that's probably messing with it too. But that's looking pretty good. I got the corner. Maybe I kind of want to get a little bit of the road in there. Not a big deal. This is much more about topography. We're not going to make roads or other infrastructure or trees or anything like that. I guess you can if you know how and you've worked with baby's breath before. So otherwise, not a requirement for what we're doing. So I'm going to take that line. I'm going to make it way easier for myself and go ahead and trim the rest. So I'm going to click on the outside. Of course, click on that picture. Oh, it looks like we can actually get both of those. So that's looking pretty sweet. And to be fair, I probably should have just made a whole copy of that. I very well might have a studio professor that goes, I actually want a different part of that. Oh man, I accidentally trimmed it away. I'm gonna have to do all of that over again. So it is actually probably a better idea, especially right now, since I just did it, to make a copy. You never know. I might have a studio professor that wants a different spot, or a client, right? I want the guest house actually over here. How many times have you heard that? I'm just kidding. It does happen a lot, honestly, in my field of work. I do a lot of high-end residential houses, some where their lots are 40 acres. And I'm literally sitting there for months studying their plot of land, figuring out for them where is the best spot for that guest house or their main house or their pool house. And yes, I wish I had these kinds of problems too. But yeah, you're very much the arbiter of truth when it comes for the location of our architecture and our designs, as you guys well know in studio. Anyway, so we're looking good. We've definitely got something to trace here. It's to scale, so let's get started. We've already got a copy of it. Sweet. In fact, I'm gonna get another copy. I can never be too careful. And to be fair, just in case I mess up, now I have one that's already ready to go. And very well, I could be thinking about diagramming or site planning. So again, looking towards the future. I can always make another 30-foot line, so I can delete that, no big deal. But in my case, actually, it looks like the satellite image is getting in the way, so I'm gonna ungroup it and either, hide it. So I can hide things too. You don't necessarily always have to get rid of things. And I wanna lock this one in place because I wanna start making that complex topography. Now, to be fair, you can see that it's quite pixelated. And there are certain plugins where I can magically make lines, such as Illustrator. I could use Image Trace, and I'll just throw these kind of terms out there for you to look at. I'm not necessarily going to go over them this very minute, though, because I do want you to get used to this process because it is the most accurate, right? And to be fair, it really starts to intuitively tell us some things, I think, even plant some seeds to our subconscious about really what's happening on the site, and starts to put us there, right? In a lack of a better sense. Anyway, so let's start tracing it. I'm gonna need some layers, so I'm gonna go to my layers panel, and of course I start afresh, so I'm gonna use actually layer 4 because it's already green. Double click, or if it's not renaming, I guess I'll just rename it topography or topo, and we'll put that one towards the top and get started. Green actually might be really hard to see. We'll find out. So in my case, I like to use, of course, this tool, the control point curve, one of my favorite tools. And for this process, I would recommend that you start drawing on the outside of it. You can always trim. It looks funkier trying to fill in the blanks. And of course, as the tutorial goes, you'll see why I draw it so far outside of the box. That way I can work with it. Because I am gonna go over several methods of turning this into a topography surface. So in my case, I kind of want to set up for future Chris, and that's looking pretty good. And yes, this process can take a little tedious of your time, and we'll ballpark it. After all, it is pretty pixeled, and I can always move these points, so not a big deal either. But I do want to get it fairly close. I can hit spacebar and spacebar again to enact the same command, making this a little bit of a faster process. To be fair, if the topographies were, really congruent and often the same, I could even use offset, right, to get some of those. Now this is where things will get a little tricky. I may have to fake it till I make it, but I think we'll be okay. But as you can see, it can get pretty jumbled up there. And as you can imagine, using plugins like Vectorizer or Image Trace in Illustrator, it's not gonna get a great version of that. In fact, there's just, it's why we're gonna always have a job when AI starts to take over, because AI is gonna go, I have no idea what line those are. Whereas a human, we know, right? We can of course make those connections on a fly. I don't know, it's my humble opinion that actually the AI systems that we have are more or less actually just really fast calculators. They're really predicting, if anything, really the statistically closest thing that you're typing, to be fair. It's not really smart. Artificial intelligence to me is more the equivalent of a light bulb suddenly becoming conscious and turning on and deciding to turn off and on, which would be quite freaky, to be fair. I don't know. I don't think we'll get there. But did happen to read an article the other day, basically saying the top 10 jobs that will go away because of AI and the top 10 jobs that will stay because of AI. And the argument for architecture and design was in top jobs that will stay because of AI. So, I don't know. We definitely still got a job, guys. That's good. Can't say the same about the workers of McDonald's, but, we're definitely going to need somebody to train and maintain all those robots. So, I don't know. I'm optimistic. I can only hope for the best. But as you can see, just making some small talk, as this can be quite a delicate process. Of course, I've had quite some practice. And you notice I'll just kind of ballpark it. Just trying to sit on the line and really just going from the previous line. I guess I don't really need to get every single one today. It is for tutorial, but we'll start to simplify it a little bit. Let's take the every other line situation. I do want to be as accurate as possible. But let's face it, we all skip this part on the YouTube video anyway, so. And this is very often why we used to say in architecture, how many clicks did that take you, right? Because this could, with Vectorizer, if it was a really nice topography pixelation, I could use Vectorizer or Image Trace, and it could be as easy as 5 clicks. Whereas you can see right now, I'm reaching the hundreds. We'll ballpark this next one. Again, continuing to go outside of the box. And fair enough. Good. So I definitely don't want to do that again. So I'll go ahead and make a copy just in case I mess up. And already it's starting to look like something that we could definitely use in architecture, whether it be a diagram now or, so it might be a really good reason to use, the two-dimensional as well. Obviously we have to make the two-dimensional first in order to make a three-dimensional model for it. Now, this is where, now that I think about it, I can think of 3 ways to actually make this topography. The first, the manual way. I don't know what else to call it. Essentially, we start with a 0 point, or you guys may be familiar with topography, but if you're not, each of those lines actually represent an elevation level, right? So if you can imagine a bunch of straight, perfect elevational levels, and of course we can use sextants, and you can learn so much actually about the stars and the longitude and latitude and actually how we even get those numbers and things like that, and coordinate systems. Anyway, not going to get too much into it, but essentially each of those represent a foot above sea level, right? So in our case, well, if you've ever noticed and looked at land, it doesn't go like this, right? It doesn't actually have those straight lines and things like that. So I do want to go over a couple of methods, maybe a much more realistic method versus what I like to call the cardboard method. Anyway, it's still in development, as you can tell verbally. So we need a 0 point, or in our case, the 0 point actually might be the edge of the model, and that'd be okay. So let's go ahead and extrude that just to kind of give myself a nice base. And I'm going to go ahead and do 12 inches. That way I can start to realize what a foot is in this scale as well. I'm going to switch to shaded. As you can see, all right, we got a flat land. So in my case, I kind of want that to be a different layer, so different color anyway, so you can see the green a little bit better. Change object layer, sweet. Arguably, yeah, I guess you can still see the green lines a little bit better. But essentially we need to put each of these up a foot, right, in order to be recognizable of the realistic topography in real life. So in my case, I'm going to use my right or my front, right, in order to raise these lines a little bit simpler. So I'll click on each one. I'll click on this viewport, type in move, click anywhere, 12 inches, enter, hold shift so that I make sure that it goes up, and we're good. As you can imagine, the next line, move, same process. I'll stick to my right. I'll go up 24 inches. And obviously you could type in 2 feet, 3 feet, everything and so on and so forth. But now we're starting to get some slope between those two lines, right? So let's continue. As you can imagine, this is going to take some time. 3 feet. But of course, we only have to do it once. Hopefully, as long as we don't mess up. 4 feet. Actually, the hardest part about this is keeping track of how many feet you're using actually. 5. As you can see, it's a pretty steep hill. 6. That space bar comes in handy too, because I'll just click on the line, space bar, click, and 8 feet, enter, because time is money, right? How dare you? Was it your phone? It's almost worse. 2 lines to go. Hang in there. Hang in there. But doing it in this process as well, actually, it's taught me that there's a 12-foot drop here, because I used a total of 12. And to be fair, I didn't know that by just looking at it in Google Maps and things like that. Of course, I could have sat there and just counted them too. But you'll realize, of course, doing stuff hands-on really, in my personal opinion, teaches you a lot more than just sometimes this technological world. When it's just sort of given to us, the information, you don't really inspect it, or in my case, accidentally went too far. 12 inches. Sweet. So as you can see, we've kind of developed more or less like a wireframe model. And to be fair, we could also use this for diagramming, right? I mean, wouldn't be a bad idea. I could make 2D and I'd still get, a nice view of it. Arguably, it would be kind of weird that there's a base in there, but it is what it is. You know me, I like to make another copy, because again, I might use that one for a diagram. And really the end goal here is to show you a couple of ways in order to make this model. Now, to be fair, I think the easiest way is to loft it. So I'll do that first. So in my case, I don't really need a base for that, but I do need this wire. And you'll see immediately why we went outside the boundaries for this. So I'll take all those topography lines. I don't actually need the bottom one. And you guessed it, we'll loft it. So in my case, it makes something pretty funky there. And you may realize, well, I'm kind of missing some pieces here, right? I actually might need some more layers in order to do that. But I will say this one leads to the most realistic view of topography. In fact, yeah, I mean, it doesn't get much better than that. This practically looks like it's full of mud and, just ready to have grass sprouting on it. To be fair, it's almost like you can see the rock formations even coming about as well. So definitely realistic and definitely something I would use if I was trying to go for some sort of realism in terms of my project. However, to be fair, most of the time we're not trying to go for hyper realistic, even though that's quite popular. And you know, if you see the architecture magazines, we see it all the time. But to be fair, I think we should be well-rounded individuals when it comes to what we need. So at least there's a realistic way. And to be fair, I do need some more lines because you can see that it's starting to fold on itself and things like that. So I may need actually, and I'll just show you how to do it, is some continuing lines. Right? So in my case, I'll line up with certain elements and basically complete the already existing line there. Right? So I just need to put it on the outside. I'm going to hold shift so that it stays basically straight. Right? And I'll basically connect those. Join. And probably need the edge over here as well. Oh, thought I typed line. Line. Beautiful. I'll hold shift so that it stays in the same plane of reference. Right? And as you can see, it starts to be a little bit bigger of a line, telling Loft exactly what to do. Right? So we'll join those again and try again. Right? Obviously, the more complex the surface, sometimes Loft isn't maybe your best option. But as you can see, it does help out, right? And definitely pulls it to the extent of where we need it. Now, to be fair, we don't need that kind of weirdness in there, so we'll end up chopping it off. But let's continue, because obviously we still got some bits and pieces to go. To be fair, there are a couple of options with Loft, right? You can close a loft. I don't recommend for this process, obviously, because we just need a single surface. But to be fair, you can test out some things like loose. Maybe loose doesn't help us out so much. I usually prefer actually tight or uniform. Even though uniform, again, it can lead to different calculations and things like that. Again, I don't want to get so much into the science of loft, but as you can see, there's some visual differences. So we could keep that and see, oh, we do have a piece missing. I guess I could cap that, but let's do it the right way. Right? I could just actually decide to close it too. I'll let you test that out actually on your own. In my case, I'm going to line up some stuff, and I just want to make sure, again, that I get outside of the box. Right? As you saw, there's actually quite a few little weird errors and things. So, and get it fairly close with that. And as you can see, quite a, we're deciding where the loft should end, essentially. So I need to join those and make sure that they're one whole piece. It's funny, I said this was going to be the easiest method. It is arguably still pretty easy. But, oh, wrong button. There we go. Unselect that one, loft. And it's looking a little bit better. And that's definitely looking a lot better, but still missing that piece. That's okay. Take a line. Oh, could swear that typing line, guess not. We'll get that piece. And basically just put it a little bit up. Right? I mean, I guess we could put it a whole foot up, but it's not technically accurate. Fake it till you make it. Right? Take that piece, try again, loft. And as you can see, we're starting to at least cover up that a little bit. And you'll notice it looks like it almost like flips around. Check this out. It's weird. If I flip it, so I'm going to type in flip, enter, absolutely nothing visually happens. But let's take a look at that loft again. It's about the same. So, I mean, well, I guess it bulges a little bit more now. But to be fair, these lines actually have a direction to them as well. So you'll notice, especially when I was tracing this, I always started at the top left and went down, top left, went down, because I want all those lines to be in the same direction. Now, it doesn't really matter if I do that from the bottom up or bottom down, but what I don't want to do is draw one here, then start one here, then start one there, then start one there, because all my lines will be actually flipped, right? So just in case you're running into that problem, I do like to mention that on this video, just so you're aware, and I like to at least show it a little bit, but usually I end up messing up my model. Let's try and flip this again, or flip another one, just so we can see what it does. So loft, Yeah, and as you can see, it made it a little bit more wild at that piece. It almost like goes up and inside of it now. So, like I said, it can definitely mess up your model if it's already correct, right? So I'll edit undo on that one. But I do want to throw it into the mix just in case you're running into that problem. To be fair, I mean, that's definitely one way that we can do it. So I'm going to take this piece, copy, and let's just sort of complete the loft method. So loft, enter, and let's say, you know, I actually got all the pieces right and everything's good, right? So we may need to wire cut this or trim it, right? So I can't really trim in this view, but I can trim in this view. Right, so for instance, I can use the border, trim, enter, and actually click on the outside. Very useful. Rhino 5 in the past could never do stuff like that. But that's actually looking pretty good. I'll hit enter, and at least it's a little bit more refined, especially for what we want to do next. Because to be fair, this would actually really be more for like, you know, if we were using a rendered view. It starts to look pretty nice. And to be fair, as you can see, I have some lines to flip. I think I remember actually I started drawing on that way for one of those. So good, able to kind of see where the mistakes are and where they need to be fixed. So this would actually indicate, oh, that line needs to be flipped. As you can see, it looks like that line needs to be flipped, and so on. Not a big deal though. Let's say that doesn't work out for you. Maybe you don't like the loft method. That's okay. Let's try another method. So I'll switch to a ghosted view, and let's work actually with this one. Now to be fair, this one actually, this next method only requires the 2-dimensional. I don't even have to do that 3-dimensionality thing yet, right? So I'm gonna take a copy of this one and place it right above. And this one, basically, I can think about it as individual cardboard pieces. So for this one, I like to start at the top, even though, of course, it's 2D, it's not really at the top. And I'm gonna go ahead and trim everything that I don't need. So all those lines that I went on the outside, those were really just for the loft. And again, I think it's actually artistic flair, but that's just me. But for this next step, I'll definitely want some easier pieces. Now, to make this easier, what I like to do is group these and probably make a copy. Because I don't want to have to trace those all over again, but I do need some extra lines involved. So for instance, there's even a couple of methods to this method, but now I have one that's basically grouped and one that is ungrouped. There we go. And I essentially need little cardboard pieces, but you'll notice I'm missing an edge on every single piece. So two things, I can either make a bunch of squares or simply just draw a line, right? Not a big deal. I'm still in the topography layer, so not a big deal. Spacebar, and as long as I don't have near on, this process won't be too shabby. But as you can see, I'm having some difficulty there, so I'm going to take off perpendicular, midpoint, point. Just want to get end and intersection maybe. Sweet. And one at a time. So obviously this might not be the best method if you have hundreds of lines, right? Because I would have to make hundreds of cardboard layers. In this case, it's not so bad. I only have 12, so not a big deal. But essentially, I could also use my polyline so that I can make that corner, hit that corner, and get onto the next piece. And I just really need to keep track of my layers. Join. And as you can see, I already have 1 complete and 2 complete. Now, to be fair, there is actually a little trick. However, it doesn't always work. So for instance, I can close this curve because technically the computer sees as a straight line as an open curve, right? It's not closed. However, if I type in close curve, it'll automatically close it for me. Now, to be fair, that's not the way that I want to close it. But again, I like to throw some things in the mix because you might pick a topography surface that does apply. So Anyway, just want to throw that in there. For my case, I really only have to draw straight lines, so it's not really a big deal. And I already have a guideline at the bottom, so I just need to join stuff. And to be fair, I only have to do this once, so not a big deal. I guess I could also make another copy of this and make it a little easier on myself. So you can actually copy in place. I didn't want to mention that. So when you type in copy, you can, that way you don't have to move it and put it somewhere else. If you do in place, of course visually nothing happens, but there's a second rectangle there, which is and can be helpful. So for instance, I could use this one and I could trim it. However, what stinks is make sure that you of course select the right one, right? Otherwise you'll get rid of both and you'll need to make a new rectangle, right? So to be fair, I mean, there's other ways than just retracing. I find it a little bit easier, and I can make sure that I get every single layer. Right, so again, that piece, hold shift, get that piece, and join them. But for the sake of time, let's go ahead and just kind of assume that I've already got all these lines, they're ready to go. So I'm going to go back to my model and focus on it a little bit more. And really just extrude. So we'll take each piece, extrude, and go 12 inches. Not too shabby. We'll take the next one. 12 inches. Oh, extrude. And in my case, actually, I might need to delete the other one from this one. I accidentally traced it backwards. So I shouldn't have gone to this edge. I should have gone to that edge. But I actually did that on purpose so I can show you what to do if you accidentally do that, right? So let's extrude it. And because immediately it's going to be like, oh wait, the topography is going the other way around, or I'm accidentally getting the topography on the other side. What do I do? So just minus it. So we can take that piece, or better yet, we can take the curve that it came from, and I can wire cut it. All the way through. So in my case, it looks like it's selecting that direction first, and that's okay. We can change it to the Z direction, go straight through, enter. And as you can see, more or less, it starts to be kind of like the cardboard model. Now, let's actually do it the right way. So in my case, it would actually go all the way around. So you'd actually go this way. And again, just think that piece of cardboard as if we were stacking it ourselves. In fact, I will say the cardboard stacking method is a good method to go right to the laser cutter. Right, so I will say that. You can kind of save yourself some time and work right there. But let's go ahead and explode this one because I don't need that corner anymore. And just so you guys can see what that looks like. We'll get rid of those curves that are hidden in there. We'll take that one now and the outside curve, join it, and make something very different. So let's take a look and see what that makes. And as you can imagine, right, extrude, 12 inches. I'm gonna go up, right, we get that little piece there. And clearly I've still got this one wrong, right? So I do need to explode that one as well. Let's go ahead and do that. And draw it the right way. We'll get rid of that one and that one. But as you can see, there's multiple methods to this, right? I mean, we could really just honestly stack up a bunch of regular rectangles and then strategically actually wire cut from all of them too, right? That's another way to do it. I'm not going to go over that today, but hopefully that makes sense. Does that make sense, guys? Right, I could just stack a bunch of these layers and then just remove as necessary or cut away as necessary. But again, I'm just trying to hit a bunch of different methods because we all do kind of something different. But let's get 12 inches on that one. And we start to get the base, everything like that. And maybe just to kind of show you what that would look like. So I'm just going to copy a bunch of these layers. In my case, I want to be pretty strategic on this one, so I'm going to take that one, stack it on top, stack it on top, stack it on. I like to do the whole motion. Very often try to make the digital realm more reality. So you have to play a little bit, right? But yeah, to be fair, I can't see anything, but I could choose a different mode. I can go X-ray. I can get some of these original curves. Now that's where I'd actually want that extended curve, because that's going to be useful to wire cut. It might not actually work in this process because it is technically on the same plane. So let's find out. Wire cut. In my case, I'll have to select the next layer that I want to cut from. So in my case, that one. Enter, and slice all the way through it. Now in my case, I want to get rid of that side. Enter. And of course, we'll have to do the whole process to finally get the last piece, but again, another method we could use, and arguably, well, easier in some situations. Now in my case, I would actually have to use this one. Right? That way I can make it a little easier for myself and just start at that place and cut up. Start at that place and cut up, right? So I'm kind of doing it a little bit wrong, at least in this section. I'm gonna have to work twice as hard and move this line first to 3 feet and then do the wire cut. Hopefully that makes some sense. Hopefully I'm not being too confusing. I try to be as organized as possible and at least show you that there's a multitude of ways. Let me make sure I'm not missing anything in topography though. So that's looking pretty good. Yeah, we got the loft model. So I do want to show, and I think I was mentioning actually this a couple of days ago, that for instance, sometimes we actually start off with this piece. We actually get a surface, and especially for studio, right? Maybe instead of contours, maybe we're out in the middle of nowhere. And let's face it, we make a lot of architecture, especially out in the middle of nowhere, Texas. So I don't know, maybe pick a crazy location like Tarpley. I've never been out there, but it does look like it's quite vertically interesting. So let's say I don't have my hydrology and contours map, and maybe I start with the surface instead. Now, unfortunately, this program, specifically Terrain to STL, it's going to make a surface for us, but to be fair, I can only zoom in so much, and it's not entirely useful, at least in a micro situation, but definitely a macro situation. Let's say I was getting that studied, so let's do it. I'm going to, of course, center to view, and I can get this little square amount. I could even change that a little bit with model details. Usually I leave most of this stuff about the same. Of course, it works in degrees, so I think it actually only goes as small as 5 degrees. I'm not sure. Oh, there we go. Oh, it's actually changed a little bit. That's good. So we can actually bring it down to 1:1, which is pretty good. But maybe for instance, especially in this project, my 48 by 48, I want to do something visually interesting. Water and base settings, I usually leave those at 0 and 2, and generate a model. So just in case we actually go the other way around, I want to throw that method in there as well. Again, this maybe actually applies more to a studio situation, and maybe not so much our assignment, but definitely useful. Now in my case, I had to generate the model first and then download. So we're going to go ahead and download and see what it produced. Obviously a very different situation than San Pedro Park. And I think it actually comes in as a, oh no, did my mouse die? Dang, after 6 months of never charging it, it finally did it. It finally died. Oh man, well this isn't gonna be cool using my trackpad, but here we go. Actually, let me unplug this one real quick. Stand by for technical difficulties. Unless somebody has a micro USB charger. Didn't think so. Let's just get this mouse real quick. Or is there one hanging around anyway? It happens, especially with battery devices. It's not the first time, won't be the last. We got a mouse going, please, please. Of course I had to pick a mouse that doesn't work, right? Allow, sweet. All right, we're back in business. So let's go ahead and take in that STL model. File, import. So in my case, I probably can just drag and drop it, but I think it comes in as a zip file first, so we do need to unzip it. Of course, on the Mac, you can use the archive utility or the unarchiver. If you're on a Windows, you can use WinRAR. It's free, so WinRAR. Anyway, most of the time we can just double click on it, and of course turns it into an STL, which is a stereolithograph file, and of course going to open up that file. In my case, not really working with a scale there, but as you can see, it's a very, very tiny model. I think it's in miles, so of course our units are pretty sketchy. But in my case, it's going to produce a nice little model. To be fair, I don't want a bunch of triangles, but yeah, it's a mesh, right? And what we know about meshes so far is that, of course, they're built upon triangles, and as you guys know, we actually make mostly NURBS. Again, that's probably an acronym that I can't remember right now. But first things first, we want to make this into the topography, right? We need some topography with it. So again, this is kind of just for really more of a studio situation. But if I use contour, right, I can go actually the other way around. So in my case, I do need to set a base point, right? So I'll go ahead and set that. And in my case, I need to choose the direction that I want the contours to face. So I do want to go into the Z direction. Now you'll notice I can't really, I can go to a vertex. That should work. There we go. So yeah, sometimes you need to engage that when necessary. Distance between contours, beautiful, 1 foot. I'm gonna make sure and just put 12 inches, enter. And as you can see, it went the wrong way. That's okay, you gotta learn somehow. That's actually kind of cool. Anyway, not what we want, so let's try that again. Contour. And I think it was because of the base point that I selected. I didn't have my vertice or vertex enacted, so I don't think it got the vertex. There it is, vertex to the other vertex. There we go, 1 foot. And that's a lot better. And arguably looks kind of familiar, doesn't it? Right? So we got the topography. So to be fair, we're not even going to use the mesh model, right? In fact, you really wouldn't use mesh models unless you're 3D printing or, again, other machining and things like that. We can also get rid of the things that we don't need. And voila, we have a wireframe model. Right? So again, there's multiple methods to this, just in case I need that in studio. And again, maybe I'm not working in San Antonio, or maybe they don't have existing topography. So I'm not going to let that stop me either, right? And of course, make my own topography sections. Just for giggles, I want to see what that looks like lofted. See if it works or not. It's questionable. Yeah, it doesn't work. And that's okay. It looks like a lot of the lines need flipping and things like that. I could explode them. I really could retrace this all. Again, it depends on the level of what I need for studio. But for specifically this class, I would suggest actually the cardboard method, right? Making one piece at a time, or the wire cut method. Honestly, that one just came to me today. So let's face it, I can say this until I'm blue in the face. There's 15 ways to do the same thing in Rhino, always, right? It really just depends on how many clicks or what level of detail and time I want to spend on that particular part. But let's continue, right? Let's say, I've got that finished piece, and I'll sort of work that actually maybe a little bit later. It is already approaching an hour, and I don't like to upload anything longer than an hour. So I think that's enough to get started, right? Scaling the image, tracing, and of course producing some sort of three-dimensional model, whether that be the loft method, the wire cut method, or the cardboard method, right? Sort of individual pieces. So I would start with that first. I think that's plenty. And I know a large majority of us are still working on the stairs. So of course, feel free to continue with that. Lastly, at least for today, I just want to get some attendance, right? See where everybody's at in terms of the stairs, or if you're still working on assignment 3, show us where you are at on assignment 3. Like I said, we're going to spend the next 3, arguably 5 weeks on this. So there's going to be tons of tutorials on this one. And we're really going to start to put this together fabrication style. And as you can tell, there's already many ways that we can just make the topography. So we're going to really get into the sauce here, or the gravy, as the current generation says. Definitely getting into the gravy on this one. Anyway, any questions about the topography so far? Anything that's come up? Magda says no. All right. All right. Well, we'll leave it there for today, so we can take this nice and slow and go through it thoroughly. Sweet.